Hey, welcome back to Fat Mama Physics. In this video, I am going to go through this source that you also see in something that I provided. I'm just going to go through it and talk about my response to it because this particular source is based off of someone else who does have good amount of experience in teaching, I guess, IB and I guess marking IAs as well. So this person's got some really good tips, but I have a few things I like to add on top of what she says as well. Also, so kind of a breakdown of what I want to achieve with this video is kind of getting you started on choosing your topic, because that's usually the hardest part. What else I like to talk about is kind of giving you a nice sense of what an IA looks like. So kind of the scope, how much you need to do, to what extent do you need to look for a research question, etc. So let's get started. Okie doke. All right. Okay, so yes, like I mentioned before, the IA, even though it's 20% of your grade, it can be the difference between the low. If you, let's say, you are sitting at between two levels. Sometimes the IA makes a difference between the lower one and the higher level. So that's kind of where it affects a lot. Sometimes the IA doesn't make a big difference because the student is just overall consistent across the board. So it really depends who you are. But don't undervalue the IA because it is it's the only thing you have control over. You have actually not only thing, something you have the most control over. And especially during the pandemic, the last cohort, a good chunk of their per final grade was based off their IA because that's the only hard evidence that IB has that is not, I guess, forecast or shadowed. What's the word? Anyways, that's not something that they cannot see, like a predicted grade from a teacher, and that's not confirmed with, say, an IB exam. So let's take a look at what this person has to say. Some myths. Ooh, okay, love it. Myth 1, your research question is worth 2 marks out of 24. That is definitely a myth because, like we've mentioned before, the personal engagement is seen throughout your paper. You can show personal engagement in something even as simple or as obscure that's very objective as the analysis. The way how you interpret your or the extra step that some students have taken with their analysis just to satisfy some sort of curiosity while staying focused on a topic has also awarded personal engagement points as well. Personal engagement most of the time scores about 1 point. It is really hard to get 2 points out of personal engagement. But what we have seen is that students who pick topics are a little bit more rigorous, but still within the scope of research and being able to find good information on it tend to do very well. Because finding a good topic not only awards these points, but it also is reflective throughout your paper, such as being able to talk about it extensively in your background information, so awarding you exploration points. Also in the analysis, having a good topic usually warrants a deeper analysis of your particular paper, so also giving you a better score in analysis. And of course, having a good analysis gives you a chance to do a good job with your evaluation because you actually have things to talk about. So having a good topic is having a good topic. It's not just a personal engagement, and it's very interesting how the criterias are interwoven together. Because having a good topic allows you to show your personal engagement, which then will ultimately help you do well in the other criteria as well. So what does she have to say? Don't waste lots of time searching for an IA topic. It's only worth. I don't actually fully agree on this one. I do agree that the fact that the research question is not just 2 marks out of 24, it's a lot more than that. It's your treatment of it and how it bleeds throughout the rest of your paper. But having a good IA topic is, if you do find a common topic that everyone has done before, but it's a topic that allows itself to be done, to be well analyzed, it's got like a solid base of background information, and it's, it's easy to do the experiment, you can still do relatively good on it. It's just that since we've seen the topic a lot, you just have to make sure you nitpick every single crook and cranny, because we know all of those crooks and crannies. So that's kind of where the idea is going towards. But yes, if you pick a topic that, gives yourself good scope, have good kind of, and of course, that's why we do interviews after you have your topics chosen. So then I give you my personal input on that as well. Okay, so I don't quite fully agree on this one. Okay, I'm just going to put a squiggly line for things I don't quite agree with. Okay, so next what? You need a completely original topic. Yes, I agree with this one. You don't have to have something that is out of the blue, or something that is unique, and first of all, it's very hard. It's almost as if you're writing a physics PhD paper. We're not expecting you to do that one. So even if you go to a source online, even if you use some of the topics, ideas are in this source, it's not going to be detrimental. It doesn't have to be completely original. We don't expect high school students to be able to do that. That's very difficult. So I agree with this completely. It doesn't have to be original, but if you're able to interject some originality into the topic itself, it usually gives you a chance to shine in your paper, because first of all, you'll be motivated to talk about it, and it'll definitely show in the tone of the voice in your paper. It will definitely help you with personal engagement if you do. But then usually, students who have an original topic completely tend to have a hard time finding background information on this one. So that's it's a balance. So that's why it's a good idea to talk about your topic, come up with it earlier, so then we can discuss and fine-tune it to be within a good scope of an IA. Okay, so yes, I totally agree with this one. Yeah, so we don't... Okay, so how to choose the perfect topic. Of course, it's a good idea to give this a good read, but let me kind of go through what this looks like. So, first of all, if you've had some thought about your IA topic already, then this is a great way to kind of narrow it down to exactly what it is. If you haven't, then you're gonna have to need spend some time on finding an area of interest. So, something you're interested about. Now, in terms of experiments for Carson Graham, the experiments tend to get good results for physics tend to be related to mechanics. So that is one of our earlier units that includes circular motion and even engineering physics. But yeah, unfortunately, we are not doing the option this year, but engineering physics does have some good mechanics experiments related to that as well. Okay, so there is that. Some students love fluid dynamics. Depending on the experiment, it can be pretty good. But anyways, mechanics is a good area. Waves can be a good area. There's few things that are hard to control and hard to be able to do a reliable experiment on, but there are some mechanics experiments, some waves experiments that are good. Like simple harmonic motion, there's a lot of good ones in that one too. Waves. Sound and light. Sound's a little harder to control. Light may be okay, but Next up is electricity. So electricity is also another good unit to obtain good results. So it's very, it's unfortunately something we don't learn earlier, but it does offer some good avenues of topics that allow for well-controlled experiments. So I would recommend these three areas: thermal, anything that has to do with thermal or temperature is often messy, because oftentimes you lose energy to the surroundings, which then gucks up your data, and which means you have to do a lot of trials to be able to achieve a certain amount of precision. But temperature is something that's done a lot because it's something very interesting, of course. So these are the areas that I would recommend looking more into for your topic. And if you're looking at specific videos to kind of give you ideas, Veritasium, Smart Destin, Smart Everyday, Physics Girl, Mythbusters, these are also good examples of where to get some ideas from. And so here's some topic ideas. This is kind of to get you started. Once you have your topic, then your area of interest, then you can totally look at different variables. Basically, you're finding a match. So it's basically brute forcing a topic out of where you're interested. So basically, how does X affect Y? Choosing two variables for that. There are many things you can look into. But the one thing we have to be careful of is what sensors are available to you to detect these things. So let's take a look at a few of them. Actually, let's take a look. Okay, so that's step 3. Okay, so what we have in the lab. Let's see. I can type this out here. We have a force sensor. We have a accelerometer. So the motion sensor. So accelerometer. Okay, and then we have force measuring motion. Yes, you've used that already. We have a pressure sensor. We'll use that one this year. We also have temperature sensors. Volume is something that you can measure with graduate cylinders, but yeah, sorry, these are the ones that are available through Pasco. Okay, so they can be hooked up to Pasco. We just got this one recently. This one is a whatchamacallit? This one is a spectrometer. And then this one measures the intensities at specific wavelengths. So usually if you're measuring absorption in solutions, or even if we have a little probe, so you can actually use the probe on, say, hydrogen lamp and look at the breakdown of the wavelengths. So that's something you can do as well. I remember we had a rotational sensor as well. We have a lot of broken sensors, which is not very helpful. But aside from that, we have digital multimeters, but meters that are able to measure voltage, so potential difference, and resistance. I think all the for measuring current, you have to we have ammeters, yes, like the old analog ones, which I don't may have some functional ones. But in terms of the digital multimeters, the fuses have been broken, so we don't have any functional digital multimeters that can measure amperage. So yes, these are some ideas to kind of get you started. Of course, if you're looking at frequency is some for sound. You can use any sort of device. Even your phone can detect frequencies and whatnot. Okay, so here we go. Here are some ideas. So basically, all of the variables that you've seen in in your unit so far, those are things you can look into. Please don't choose variables that you cannot measure or quantify, because you want to develop a quantifiable relationship between X and Y. So this is a good, that's a good tip. So don't choose variables that are discrete or very qualitative in nature, okay? And of course, I didn't read that the next section properly because this is talking about X variable, ha 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 ha. But anyways, essentially what you want to do for your X variable is the one you're changing. You need to be able to change it reliably and with a good amount of range to give you a good sense of your relationship. So your Y variable, this is kind of where the sensors I was talking about is applicable here, because you need to know what sensors you have to be able to know what your capabilities are. So yes, it is possible to do this with Logger Pro. Range of projectile, rebound height, velocity, temperature, power. I guess depends. I suppose depends on what power you're looking at. Acceleration is doable. Time current. Current, we have ammeters, the analog ones. We're looking into a Pascal sensor. Resistance, yes. Frequency, yes. Okay, so think about what you're able to measure. Okay, yes, so try to pick something that you can measure, and measure reliably is something to consider. So ultimately, your research question should look like this. How does blah 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 affect whatever your y variable is, and then usually have a context. So in the context of blah blah blah. So for example, what's a good example? Let's say you're measuring how the period of a pendulum, how the length of a pendulum affects its period for a period swinging in simple harmonic motion, or something like that. Because for simple harmonic motion, you need the pendulum to be swinging within a certain angle ranges, and you can even specify by the length of the pendulum. Anyway, so essentially giving your experiment more context. Okay, please choose 1-to-1. So have one independent to one dependent. Do not have two independent variables. You're not doing a study of any sort. This is not the purpose of the experiment. If you're thinking that, oh, if I have to do two in order for my research question to be complicated, then that means you need to look for a more complicated research question, or just stick with one, one-to-one. Okay, it's a one-to-one matchmaking system. Haha. Okay, so how does the radius affect time period of a satellite? So 1-to-1. Okay, so these are other examples and a whole bunch of ideas that you can take a look at. Again, we talked about the topic. It's not the end of the world if you don't have one that's completely original. So, here's more 12 investigations you can complete at home. So they kind of give you some ideas on how to formulate one. The one with the wine glass, this is very common. It's a very common topic picked. What else is pretty common? I remember there's one on, I just mentioned one earlier. There's the pendulum one is very common. What's the other one? The refractive index and the concentration of sugar or whatever is also very common. I got 3. Oh, how many did I get? 1, 2, 3. I think about 4 of them in the last cohort. 3, 4. And a good question is that if within the same class, it is with the same cohort, it is recommended to not share the same topic, or at least have some small differences between one research question and the other one, but sometimes it's unavoidable and I have to make the final judgment call on that one. So try to find, try not to, try to mooch off of a friend's topic and alter it. I mean, that's kind of last resort, in my opinion. There's so many topics out there. Try to do something that you like and is relevant to you. Okay, oh, please don't do this one. The height of the ramp and the time taken for a cylinder to roll. Ooh, actually, the rolling is interesting because the rolling is rotational dynamics. But sliding, please don't do that one. Okay, and this force of impact. Yeah, it's pretty common. This one's pretty common. The sag. Okay, so there's a lot of ones, but there's 10 questions to ask yourself. Oh, for simulations, don't do a simulation. Just don't do a simulation because there's not too much you can talk about. It really restricts your application of critical thinking because there's so many sources of errors that you can't talk about that the simulation just takes care for you. Oftentimes you kind of have to break into a simulation. You actually have to figure out the code or exactly how it's programmed for it to spit the data out. So essentially you need to know all the assumptions the simulations make. It's not very easy to do that, and just don't do a simulation. Not recommended. It will really restrict the amount of points you're able to score on an IA. Okay, so this source mentions a good amount of There's some interesting simulations. They're pretty fun, but I just don't recommend this one. It doesn't show a lot of personal engagement as well, because personal engagement, oftentimes, conducting experiment allows you to show your personal engagement there as well. So coming down here, oh, that's a good thing to talk about. So your IA is 12 pages. Not that it's super important at this stage, but think about this again. It's all about the scope. You don't need a title page. You just start with your research question at the top and then just start, essentially. Don't waste time on any of that, on the formalities, because the IB examiner is not going to care. Also, if you don't have your references within the 12 pages, it's not going to be the end of the world. But basically, think about this. Your examiner stops reading after 12 pages. So if you have anything outstanding that's important, then they're not going to read it. So that is, I agree with that one completely. Okay, so this source goes into kind of introducing each of the sections, which is, I think, a great start for you when you actually write your IA. Oh yes, having a diagram is fantastic. It really helps communication. It also gives your examiner a better idea of what you're doing, so they understand your apparatus, your setup, etc. Yes, that's interestingly there. So having a method, you can have bullet points. That is totally fine, or listing it out. But try to keep it simple, but focusing on how you're going to collect the data reliably is the key thing to focus in your procedure. You should not include appendices. Don't include the suites of data in appendix. You need to find a way of representing your raw data clearly and concisely. I agree with this one. So yes, if you have a whole lot of data, then it is a good idea to summarize it in a table and present it in the bulk of your paper. But if you have extraneous data, if you have so much other data that if you mention something about that in your paper and you need some reference to, I'd say, put in the appendix. It's not going to hurt you, because even though if the examiner is not going to see it, they know where to find it if they really have to. So should not, it's not necessary, but if you have to use it, don't be afraid to use it, is what I'm saying. Yes, please have process data as well as raw data, so that is good to have. So having a graph, we've talked about all this before. This is kind of introducing the sections here. I'm just talking about these big things. Weaknesses are sophisticated. Yes, we've talked about focusing on methodological issues as opposed to procedural issues. So focusing on the nature of the experiment, or something about the experiment that is not so easy, if not it's difficult, if not impossible to change, which had an effect on your experiment. Okay. For example, a very easy one to consider is air resistance. You can never take away air resistance. It will always have an impact on your data. Friction, energy loss, those are methodological examples of methodological issues. I can't talk. Oh, hey, look, the sample IA. Okay, so I am going to, I'm not going to talk about all this in detail, maybe, but I went through it, and I don't completely agree with this person's marking, but part of it may have to do with the topic chosen. So I will actually, here, let me just summarize it for you, and then I have one more important thing before this. So if you want to really just skip this part of the video, you're welcome to do that. But here you go. I thought this person got 23 out of 24. I think I docked 2 marks off, so I really think this should really be a 21 out of a 24. This paper is not strong enough to be within a high 24 score, so I'll talk about why later. So one personal engagement got docked 1, analysis got docked 1 mark, and parts of it were just like, I really want to dock a mark, but it's not, they haven't done so little that warrants a loss of a whole mark. Okay, so we'll go over that in shortly, but I want to talk about these other little tidbits of information that'll help you. So Doesn't matter if you're HL or an SL, the expectations for the IA is the same. So SL, you're expected to have a good, topic and as sophisticated as HL. The sophistication level is the same. So HL's good for you for choosing HL, I guess. But the SLs, you'll get I'm gonna quote compensated in a different way. Not the focus of this video, so I'm not gonna talk about that. You can ask me later if you want. Don't spend hours agonizing over a research topic. It does not have to be unique. Even if you found it on the internet, it's okay. Don't copy the report. You have to write the design and everything yourself. Yes, I agree with this one. So if you are just really stuck, you can think of an original topic, and don't be shy to take a look at some ideas. Don't include a title page, not relevant. Yes. Yes, a single well-defined independent variable and a quantifiable dependent variable. Yes, that is very true. It's a one-to-one match. Absolutely. Don't investigate two independent variables. So don't look at no triangle relationships, please. Just one-to-one, okay? Please don't put fluff in the beginning of your paper. So I was fascinated to learn, blah, blah, blah. I was interested in this topic since I was a child, blah, blah, blah. Please don't do this. These are just examples. Based off of what you're saying, in your intro and your tone of voice, everything, we will be able to tell whether or not you're making things up. So again, show, don't tell. Show that you're interested by actually doing a good job in the paper and looking at the background information, investigate it thoroughly, all that kind of stuff. Don't give far too much background on material that's not related to the research question. That is true, you're restricted by the 12-page limit. You want to stay focused because that's also part of the communication score as well. I don't quite agree with this one. I do think it's a good idea to have a photo of your apparatus because, first of all, it shows that it doesn't fully show, but to some extent, it kind of shows that you've done the experiment. Of course, there's no video of you doing it, so there's not 100% proof. But for me, it shows a level of personal engagement that you're doing the experiment. And the only thing you don't want in here is don't include yourself. Nothing personal. Don't have any don't do it in front of a Canadian flag. Don't do it in front of our school logo or something. Nothing that gives away your identity as a student. So that's the only thing you don't want to include a photo of. Like, even if it's your hand and it's, I don't know, I know you got a tattoo on your hand or something, nothing that gives any sort of identifying information about yourself is what you want in your photo to be. Although this is very true, if you can show your apparatus, if a sketch is better, or if you draw the diagram out yourself, it's going to be more clear than the actual picture itself, then what I would do is I would have a small picture of a small photograph somewhere on the side that it doesn't take up a lot of space, and have an actual diagram of your setup that is properly labeled and everything else. So the clarity is important, but I wouldn't just rule out saying don't include a photograph. Photograph is still helpful. And I actually like to see the photograph because it actually allows me to visualize how doing the experiment would be. Do include quantity, the units, uncertainty in the column? Yes, sure, absolutely. Basically, can you draw a good data table? Don't include your unit notations in italics. The paper that you just saw, that you're going to see, will have done it. Know the difference between this. Ooh, yes. So, here we go. So, having a space and not having a space. So, generally, where you want spaces, if you have a number, you want a space and then a unit. If you're writing uncertainties, then, for example, 4.0, space, plus minus, space. Oh, shoot. I totally did this wrong. So 4.0 centimeters, space, plus minus, space, 0.1 space, centimeters. So it's so having a consistent use of spaces, that's one thing. What this bullet point is talking about is the difference between the inverse of milliseconds and meters per second. So notice that if you have a space here, which you've seen here, the -1, the exponent of -1 applies only to the s and not to the whole ms. If it's no space, then this -1 applies to the entirety of the ms, which means 1 over milliseconds versus meters per second for velocity. So yes, please be careful of spacing. Show an example. A sample calculation is good. On Excel, it gives you these correlation coefficients. Just don't talk about them. Because why? You don't have a, it's very mathematical in nature. For you to be able to fully explain it very well, not very easy, and most of the times don't apply to our physics experiments. So please don't use the correlation coefficient. Don't construct based on the extremities of the first and last point error. Yeah, so it really depends on your data. It really depends on your data, your spread of the data, and again, sometimes you kind of have to base it on your personal judgment. So there's that. Please don't say anything such as "I proved." That is, it's every time I see the word "prove," I cringe. So please don't do that. Okay. And then last but not least, pleased with my results. Again, it's about showing and not telling. 12 pages or less. Word count with it doesn't really matter. Just 12 pages. Also, students, once you've seen reports later, I can show where students have squeezed every part of their paper for space. And it's totally possible to get a whole whack ton of words. But basically, just, your examiner's reading your paper. And if they see too small of a text with very little spacing, they're not going to be too happy reading the paper. It's going to affect their mood and potentially, it ideally shouldn't, but, something to think about. You want the examiner to feel like they've been taken care of. That's kind of where it comes down to. Okay, notice that this video has been this long. What I'm going to do is I am going to just talk about the segments where I've docked the marks off and why I thought they dock marks off and why I chose to dock the mark off there. So if you want to just cut yourself off this video, I actually hopefully will get this done soon, but you're welcome to you stop the video here and watch it for later. But let's take a look at the topic, the paper itself. So why did I choose, so first of all, what is this paper about? The paper, this experiment, is about looking at the relationship between the radius of a whirling bug versus the time period of one swing. So you can take a look at the rest of my notes for things that I've liked, but essentially if we take a look at the experiment, this is what it is. You take the bung and you tie it to a string. It goes through this loop here. This glass tube or whatever tube comes down. There's a paper clip to track how far this bung has swung, and then there's a weight here. So if you swing this around, this bung is actually this mass down here is not going to move because the if you look into centripetal acceleration, the tension in the string is going to be the same as the force due to gravity, which then is going to provide the centripetal acceleration for the bung to be swinging in a circle. The bung has a tendency of wanting to leave the circle while so wanting to pull the mass upwards, but then within a certain level of control, this mass should not move so much, otherwise it will affect the radius of this bung, which is a big part of the source of error in this experiment, as well as the angle, but we'll not talk about that. So anyways, this is the experiment. It is actually part of our syllabus. So if this was actually done by a student, the student would be deducted for the personal engagement because it's something that and I will definitely not allow you to do such an experiment if it's something that's in our prescribed experiment. But assuming, let's say this was not, okay, if this was not a topic within our syllabus, I would still drop the personal engagement score down by 1. A couple of reasons. First of all, even though the paper did a relatively good job with the background information, the carry out of the analysis and evaluation, it's done a solid job. But overall, there hasn't been a good amount of spark to it. So what that means is something that, if this particular topic was not part of the syllabus, I would imagine a lot of students would have done it. So it's one of those common. It would have been one of those common topics that I would see, and in order for the student to achieve a level 2 marks on personal engagement, they would have to do something that's a little bit different, or something that is a little bit more creative in their approach. So some couple of things that I may recommend are one of the things that would help the student in this aspect is there's a lot of comments I wrote about the relative completeness of the student's paper, especially where this is kind of where I would have said, oh, well, you know what? In the exploration, the student didn't do this part quite well, but it doesn't allow the student to drop 1 mark completely. And let's say the student did that for, say, the evaluation, for the communication, then this is where I would be able to actually factor in that loss of a whole point. So in the personal engagement. So let's talk about a few things I thought the student could have done a lot better in those sections. So for example, in the exploration, which I've not deducted a whole point for, is I would have appreciated the student. Let's see. Okay, so yes, the student didn't quite address why they only used up to 1 meter for their data range. So being able to give some more rationale to this one, the student also didn't justify their controlled variables. So talking about why these need to be controlled. In fact, for some of the IAs my examples that I will show you, the students have fully justified the control variables to receive up to a level point of 6. But considering the good job, the other parts of the paper for this section, I could not justify a whole drop of a whole point. So this is where it would have seen an effect. So that would be the biggest reason is for this section. In the analysis section, I will actually drop the whole point for. But throughout the paper, there was just a few misses in communication. So, for example, let's talk about significant figures. So significant figures were a problem in this table and in this segment here, but it's only there's only 2 parts within the whole paper, and everything else the student has done a relatively good job. I can't justify dropping communication to 3 points, but that's assuming they did everything else very, very well. And I would say so. The language they use is very clear. They use these equation tags. They didn't have image captions, unfortunately, but I would say overall they did a relatively good job with communication. A few things could be elaborated a little bit more, but not enough to actually deduct a full mark off of communication. So that's where kind of I would have dinged them for personal engagement. It's just the whole entire treatment of the topic. So even if there's any spark of creativity, anyway, they treated this a little bit differently. Like they did something with the y-intercept, or anyways, there's so many. I guess I'm not creative enough to be able to do something off the bat, but that's what personal engagement does. The other segment is analysis. So I would say that the student did not have any qualitative data, so that's one reason. Another reason is even the examiner, the person who marked this, had themselves that the amount of data only goes from 0 meters to 1 meter, which is not a good of enough data range, or we didn't see the justification for that. I would have dinged them here in the analysis section. And because there's a lot of reasons that kind of build up here, and including not having enough qualitative data, The uncertainties are not well explained. They could be justified a little bit better. And also the research question is, the conclusion, there's some problems with that one as well. So let's take a look at what I mean. So yes, there's no qualitative data here. And yes, the person explains here they've chosen this uncertainty because the precision does not accurately represent the blah blah blah, but then there's no tie-in from the experiment. Like there's no evidence from the experiment to justify exactly why it is this value. So the rationale, a better rationale I would have appreciated for this segment here. The what's this? The person says here the percentage uncertainty is as 12%, which suggests that the precision of the results could be improved. In this particular, your percentage uncertainty, so how much this deviates from the gradient. So the gradient here. So they're talking about this gradient and how much the uncertainty is of this gradient. So they talk about essentially the spread of the data, how much they spread from away from this best fit line, which is not accurate, because if I have a data point all the way over here, that may not be due, and let's say my best fit line becomes this, then everything else is shifted a lot. That's not due to the fact that there's a precision problem, because this could be by nature of the experiment. For a very good example is, like sometimes there are graphs that spike up and then they come down, or there's a little spike here because of an abnormality, and that's that's by nature what the experiment is. So if you have that, that's more of a conceptual, maybe systematic error instead. So you can't just say that this is a precision problem if your data points don't lie close on the best fit line. We don't even know if the best fit line is accurate or not, because we need to support it with, of course, scientific literature. So by that statement, I cringed a little bit at that. So that was that. The student also could have, I wonder, so notice that the student also can confirm the few values in the slope. For example, the mass of the bunk and the mass of the mass that is hanging. So the student could actually have done a percentage difference calculation to quantify the accuracy of the slope as well. And that was not done, so I thought that was definitely lacking. And in fact, that would have also affected the evaluation score, which could have been 4, and I would have agreed with the examiner that it could have been dropped down to a 4 as well. So the student, I would say, lies between 20-21 points. To be on the safe side, I would say 20 points in case of moderation. So that is that's where the student fell short in the analysis. But otherwise, I mean, it is a good paper. I would I personally have given it 20, but there it is. Hopefully more examples I will show later give you a better sense of a good paper. I would say I have example papers that are better than this one, okay? But I can't show you this one now, because I still want you to actually think about your topic and collect the data before I show them to you. So if you watch this video up till now or put it on fast play, you are awesome and amazing, and I don't know how I talk so much. But imagine I do this in class, how much class time I would have wasted. So I really appreciate the fact that you stayed behind for this. And of course, this last page is advertisement. Okay, well, I really do hope that these sources are going to help you and in your IA. So I'm going to stop the video here. I encourage you to ask any questions, but based off what you've seen, hopefully the take-home message is try to get your topic as early as soon as possible. Run it through me once, if not more times, and that way we can give you a good scope to focus on your research and your investigation. Also notice the amount of dedication and work that goes into an IA collecting data, and that doing that all in your grade 12 year means that it will compromise your learning in your grade 12 year of the harder topics that may come in grade 12. So having this done earlier is going to really help you. The goal is to hopefully get your data collected before you go off for the summer. So you may even get a rough draft started by the end of summer, and for me to give you feedback and whatnot. I can only give you one official feedback, but you're always welcome to come in for questions on an individual personal basis, okay? So that's my ultimate message for you. Start early, get it done before grade 12. Fat Mama Physics. Thanks you for watching and signing out.